Okay, Assalamualaikum. My name is Muhammad Rahimi and I am going to introduce about our solution and our problems. Okay, let's proceed to the question. The question, you are required to design the IPv4 and IPv6 network addressing for the network topology in figure 1. The solution of your design must adhere to the theory learned. It must include VLSM for IPv4 network addressing. So that is our question, and let's proceed for the definition of IP address, subnet, IPv4 and IPv6. Okay, what is IP address? An internet protocol address is a numerical label such as 208.109.181.228 that is linked to a computer network that communicates using the internet protocol. An IP address serves two purposes, which is the host or network interface, and it identifies a location. As you can see on this picture, which is IPv4 addresses contain of 32-bit. As you can see, each number or each of this number contain 8-bit, so there is a 4, and we can add all of them will equal to 32-bit. Next is subnet. Okay, what is subnet? Subnet, also known as a subnetwork, is a logical division of an IP network. Subnetting is the practice of dividing a network into two or more networks. Computers in the same subnet are addressed with the same most significant bit group in their IP addresses. As you can see, this is the subnet mask. Next is the IPv4. IPv4, the fourth version of the Internet Protocol is known as IPv4. It is a core protocol of standards-based Internet working methods used on the Internet and the other packet switch network. As you can see, this is the picture of IPv4, which this is the layer of the IPv4. What is IPv6? The most recent version of the Internet Protocol, the communication protocol that provides an identification and location system for computers on networks and routes traffic across the Internet. This is the meaning of the IPv4, and the pictures on that appear on this slide is an example of IPv4 addresses which contain a routing prefix, subnet ID, interface and interface ID.
Alright, so next for VLSM IPv4 network addressing. So first, what is VLSM? VLSM for variable length subnet mask, and it refers to a subnet design that employs several masks in the same network, which is multiple masks for various subnet within a single class. That is class A, B, C or network. It is used to improve the usability of subnet, which can vary in size. So next, what is IPv4? Internet Protocol version 4 is abbreviated as PV4. It is underpinning technology that allows us to connect our devices to the internet. When a device connects to the internet, it is given a numerical IP address. So next, for the topology for my question, as you can see here, there is 5 LAN and 1 WAN right here. The one is between the router 1 and the router 2, and the other LAN is first for the internet, home office network, server network, home office network, Wi-Fi network, home entertainment network. Okay, so first for the LAN 1 office network, number of hosts needed is 3. So this is because the number of hosts needed is represented as 1 for each user or devices. So as you can see here, there is the number of hosts needed is 3, and the LAN home office network is 3 also. So as you can see here, there is one network printer, PCB and PCA. So each devices and user represent as one host. So as you can see here, the IP address that the class that being used for this topology is in class C, right? So as you can see here, for the class A, the host number is at the bottom, at the behind one. So in class B, there is half the network prefix and host number, and the class C represent the network prefix and one host number. Alright, so for calculation for LAN and WAN, so as you can see here, the IP address is 192.168.10.0/24. Why /24? This is because when class C, the subnet mask will be started as /24. So for the fixed subnet mask for class C, so there should be 255.255.255.0. So as you can see here for LAN 1, there is 3 hosts, and the number that are almost near to the host is 2 power of 3. So 2 power of 3 become 8. So the power of 3 will become the number of hosts, and the other 5 will become net bit. So the complete one cycle will have 8. So it will be about 5 net bit. So that is why it's become 192.168.10.0/29. So this is because 5 net bit is added to the 24 right here. So it will become 29. Right, for next, as you can see here, most of all the hosts are almost the same. So next we will proceed to the one host. So one host, the nearest one is the 2 power of 2, so which will become 4. So there is 2 host bit and 6 net bit, so 6 is borrowed. So it will become 192.168.10.24/30. So this is because the 6 net bit is added to the 24. So as you can see here, why the last number will change. This is because the box method that are using to calculate in this solution. So as you can see here, this is the box method. So as you can see here, the box method will cut into half as the number become lower. So as you can see here, first will be started as 3 hosts, and then 2 hosts, and then 1 host. This is why the number eventually become different. So firstly it will become 0.0, 0.8, 0.16, 0.24, 0.28, and 0.32. Alright, that is all for me. Thank you.
Hi, Assalamualaikum. My name is Syamhan Rami bin Syammuhtar. I'm gonna present to you about the IPv6 addressing. Okay, let's take a look. Okay, first of all, what is IPv6? Okay, IPv6 is Internet Protocol version 6. It's the most recent version of the Internet Protocol, the communication protocol that provides an identification and location system for computer on networks and route traffic across the Internet. To configure the IPv6 at devices, there are 3 ways, which is basic IP configuration, configure using CLI, using console cable. Okay, firstly, configure this one. For the example of configure using basic IP configuration, I choose PC. We also can do at, for example, server and smartphone. Okay, to configure the IPv6, we just click at the PC, and then this display will by looking at the display, we know that the IPv6 configuration is just at the bottom. So we just fill up the IPv6 addresses by fill up to stable. Then we are already configure the IPv6 at the PC or server or smartphone. Okay, next is for configure using CLI. Okay, this one I choose router for CLI example. Okay, what we need to do is we just click at the router, and
it will display physical config CLI and attributes. Just click at the CLI. Okay, CLI is a command line interface iOS. Okay, by click at the CLI, there are a few things that we can put to configure the IPv6. Okay, for example, we need to enable first, then we need to configure terminal, which is because we want to configure the IPv6. Okay, next we need to choose which interface that we want. Okay, at this example, I choose G0/0/0. We also can do an interface G0/0/1. This one is just example. Okay, by choosing the interface that we want, we will enter the config if. By enter the config if, what we need to do is we need to just write the IPv6 address and put the address that we want to configure. This one is just example. Then after we configure the IPv6, and then we tap no shutdown and we exit. Exit means that we exit from the interface that we were in before. Okay, next is configure using console cable. Okay, this one also I choose router as the example. We also can use the Swift to configure at other component. Okay, for example, we take the console cable, which is the blue one, and connect it to PC, which is to RS something, and connect it to router to the console port. Then we click at the PC, then we choose desktop at the option, and then we click at the terminal. By click OK, then we will enter. We can configure the router by when we were at PCA. The configure using console cable is the real life method, and basically we use this console cable. Then CLI is just for easy student using Cisco Packet Tracer. Okay, by enter the PCA, we can configure the router. For example, we can just enable, and the same command as before, which we need to configure terminal because we want to configure the IPv6, and then we choose interface, which interface that we want, and then we type the IPv6 address. We also can put the for example IPv4, which is we just need to remove the v6. Okay, for the okay, and then we put the IPv6 configuration, and then no shutdown, and then we just can exit by tap exit. Okay, that's all for me for the IPv6 configuration. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. So my name is Izzat Wakil. So I'm here today going to present about the ping test for our assignment videos. So here, as you can see, this is the network for the question given, and this is the topology for the network. So as you can see, there are 1, 2, 3 and 4 and 5 subnets to configure. So let's take a look at the first one, which is the internet and the internet modem, which is we actually did not want to configure it because it's already configured. So we go to the Office server network. To configure the server, we use the router and assign it to the IP address on 192.168.0.29 for all the interface for gigabits. So home office, as you can see, the IP address over there, 10.3, 10.4 and 10.5. And I also key in the IPv6 address, as you can see over there. So the default gateway is 192.168.10.1, and for the Wi-Fi network we assign it manually for wireless 0, 10.10, 10.11 and 10.12 here, and also the IPv6 we also key in. And for the last home entertainment network, we just only assign for the entertainment server. IP phone and smart TV should not be key in the IP. So as you can see over there, 10.19, and the switch 2 we assign the VLAN 1, the VLAN 1, and also the switch 1 for VLAN 1 also, and we assign the serial connection interface, as you can see there. So let's test the ping. So we go to the PCA ping 192.168.10. This we ping to the PCB and printer, and also the router and switch. So we ping the router first successfully, and next we ping the switch. Take a while, but it should be successful, yeah, as you can see there. And 10.4 for the PCB and the printer. Okay, now I will ping to the router through and go through the server. So which is the server IP is 226. So we put in, and we should get the ping successfully, as you can see there. So next we use the static routing, as you can see over here. So, as you can see, I assign the IP route for the router to router, and this is the IP that I assign. So therefore we can ping through the next router to the router 2, and I will ping to the entertainment server 19. So 19. So see, it will be successfully, and I can ping through the wireless device too, which I will ping to the smartphone. This is 10.10. So I will ping to the smartphone, and it should be successfully too. As you can see there. So therefore this network have been tested for every device and can be communicate with each other through the home network. So that's all for me. I will give to the next presenter. Thank you.
Alright, let me continue. For the conclusion, for the configuration, we successfully configure all the IPv4 and IPv6 address. And for the device and user, each device and user are successfully can be pinged with each other. For the system networking, we successfully complete all the simple networking system. Okay. Alright, that's all from us. Thank you.